So today we're going to talk about composition of functions. So it's like composite of functions. You're going to combine functions, okay? So the way that they denote this, the notation for it, usually you see something like f of g of x, okay? This is not fog x. This is not f times x. This is f of g of x, okay? This isn't a closed circle. It's like an open circle, kind of like an O, okay? But the way you read this is f of g of x, okay? And what that really means, think about when we just say f of x, right? We have f and then parentheses, you put your x. We're saying f of g of x. So we're saying f of g of x. What this means is that you are putting your g function inside of your f function and you are combining the two functions, okay? Another way you could see it is just switch around, g of f of x, okay? Similar to above, but now this is g of f of x. So now you are putting your f function inside of your g function, okay? The best way to really learn this is just by looking at an example of what I'm talking about. So let's look at our first example. All right, so for our first example, you're given the function, the f function, which is 4x plus 3, and then our g function, which is x minus 2. Okay, so for example A, we're going to find f of g of 3. And then for example B, we're going to do g of f of 3. These are different, and that's what I want to show you. Okay, so let's look at this first one, f of g of 3. Okay, when we have the f of g, it's like the one above, f of g of x, we're plugging in the g function into the f function. The only difference here is that instead of an x, we're given a value for x. We're given that our x is 3, right? So really f of g of 3, that's the same thing as saying f of g of 3, okay? So what that means is we're kind of going to start in the middle and just kind of break this down slowly. So the first thing we're going to look at is we're going to solve g of 3. Okay, we've done that before with function notation. That's where we're going to start solving this. We're going to look at g of 3 first, find our answer, and then we'll plug that answer into our f function. I'll show you what I mean. So we're going to focus on just this part right now. Okay, so I'm going to take my g function, but I'm going to solve for g of 3. If you recall from what we've already done in the past, that means wherever I have an x value, right, we're replacing our x's with 3. So g of 3 is equal to, instead of x here, we're replacing x with 3, right? So g of 3 equals 3 minus 2. And 3 minus 2 gives us 1. So g of 3 is equal to 1. So if this is equal to 1, then I'm replacing this with 1, and I'm now going to find f of 1. Do you see what I did there? I solved this part, so I simplified it to equal 1, and now I replaced this whole thing with 1, which is what it was equal to, right? So now I'm going to find f of 1, which means wherever I have an x, I'm replacing it with a 1. So f of 1, I'm going to bring my 4 down, and then, these are two different things. Bring my 4 down, and then instead of x, I'm putting with x is equal to, which is 1, plus 3. And then we're going to simplify. So 4 times 1 is 4. And 4 plus 3 gives us 7. So 7 would be our answer. Okay, same equations, but different compositions. So this time we have g of f of 3. Okay, so another way we could write this would be g of f of 3. So for this one, we're going to start in the middle again. We're going to start by just solving this inner part, the f of 3. Okay, so I'm going to go over here and I'm going to solve f of 3. Meaning we're replacing our x's with 3, right? So I'm bringing down my 4, that's not changing. But instead of an x, we're putting a 3. And then we're bringing down our plus 3, and we're going to solve. So 4 times 3 is 12, and 12 plus 3 gives us 15. Okay, so since we know f of 3 is equal to 15, then instead of f of 3, I'm putting what it's equal to. So I'm going to find g now of, we're replacing it with what it's equal to, which is 15. Okay, so I'm going to come down here and I'm going to find g of 15. So I'm going to look up at my g function, and wherever I see an x, I'm putting 15, right? So we'll have 15 minus 2, and 15 minus 2 gives us 13. And that's it. All right, example 2. We have 4x plus 5 for our f function, and for our g function, we have 2x plus 1. So for a, the first thing we want to find is f of g of negative 1. I'm going to go ahead and rewrite it because I think it helps. So we're going to look at it as f of g of negative 1. Okay, we all know what that equals. And then for b, we have f of 2. You can see that. That's perfectly fine. You could have g of 2. Doesn't matter. Okay, so we're going to find f of 2. Okay, meaning we're just plugging into our f function 2 times, right? All right, so let's take a look at this first example here. F of g of negative 1. So we're going to solve just this first portion first, okay? We're going to find g of negative 1 first. So I'll even label it. Number 1, first thing we do is we're going to find g of negative 1. So we're looking at our g function up here, and wherever the x's are, we replace them with a negative 1. So this will be 2 times, instead of x, we're putting negative 1 plus 1. Okay, and then we're going to simplify that. So 2 times the negative 1 is a negative 2. I can write it if it helps you. Bring down your plus 1. And negative 2 plus 1 gives us negative 1. Okay, so g of negative 1 actually ended up equaling negative 1. Okay, so in this case, g of negative 1 equal negative 1, right? So then we're replacing this whole part with negative 1. So we're now finding f of negative 1. So that's going to be our step 2. F of negative 1 equals, so we're going up to our f function, and instead of wherever we have an x, we're putting a negative 1. So we'll have 4 times negative 1 plus 5. 4 times negative 1 gives us negative 4 plus 5. Negative 4 plus 5 gives us a positive 1. That is our final answer. We now found g of negative 1, and we found our f of negative 1, and our final answer is 1. Okay. Now for b, we want to find f of 2. Okay, so we're just going to take this piece by piece. First thing we're going to find is f of 2. Okay, so I'm going to my f function, and I'm bringing down my 4. And then when I get to x, I'm replacing x with 2. And I'm bringing down my plus 5. So we get 4 times 2 is 8, plus 5 gives us 13. So f of 2 equals 13. So up here, we're going to replace f of 2 with what it's equal to, which is 13. And we're bringing that f down. So now we need to find f of 13. So we're going back to our f function again, bringing that 4 down, and instead of x, I'm putting 13, and then bringing down my plus 5. Okay, and then we're going to solve. 4 times 13 is 52, and 52 plus 5 is 57, and that's our final answer. Okay, example 3. So for A, we want to find f of h of 0. Okay, this one's actually 0. Should have done a lot bigger, but that's a 0. This one's our of. Okay, so we can rewrite that to be f of h of 0, right? And the first thing we're going to look at is we want to look at the h of 0. So that's the first thing we're going to do. Meaning we're going to look, if you notice, we have 3 equations or 3 functions. We have our f function, our g function, our h function. So we're going to take our h function and we're going to plug 0 in for the x. Okay, so I'm going to bring down this 4. And then instead of x, I'm replacing x with 0 here. And then I'm bringing down my minus 1. 4 times 0 is 0, and 0 minus 1 gives us a negative 1. Okay, so h of negative 1. H of 0 equals negative 1. Okay, so we're going to replace h of 0 with what it's equal to, which is negative 1. So I'm bringing this f down because we haven't solved f yet. We've only solved h of 0. Bring the f down, and replacing h of 0 with what it equals to, which is negative 1. And then that's going to be my second step. I'm now going to solve f of negative 1. So I'm going to go to my f function. And I'm going to bring my 3 down, and then instead of x, I'm replacing it with a negative 1. And 3 times negative 1 is a negative 3, okay? So that is what our final answer is. Second one, for B, we have, this isn't hog, this is h of g of 5, okay? So we can rewrite it, h of g of 5. Okay, and we're going to solve that first part first. So g of 5. So I'm going to look at my g function. And I'm bringing down this 3 minus, and I'm plugging in a 5 for my x. So 3 minus 5 gives me a negative 2. So that's what my g of 5 is equal to. So I'm replacing g of 5 with negative 2. So I'm bringing down this h, and I have h of negative 2. So that's what we're going to be solving next. H of negative 2. So we're going to look at our h function. We're going to bring down that 4. And for where our x is, we're going to plug in negative 2. And bring down the negative 1. Okay. 4 times negative 2 gives me a negative 8, and negative 8 minus 1 gives me a negative 9. And that's our final answer. Okay, so we're going to use the same functions from above. We're just going to do a couple more examples from it. So if you see an example like this, f of the inverse f of 6, okay, you would need to first plug into the inverse function of f, okay? So let's first find that. Step 1 is actually to find the inverse function. So we're going to take y equals 3x. I replaced my f of x with y. And to find the inverse of that, we're going to switch our x and our y. So I would have x equals 3y. Okay. And then we're going to solve for y. So I would divide both sides by 3. And I get that y equals we usually write it as a 1/3 times x, okay? This is our inverse. So then I want to find the inverse function of 6. So step 2 would be the inverse function. I want to plug in 6 into that wherever I have an x. So I'm going to have 1/3, and instead of x, I'm putting in a 6. Okay, 1/3 times 6 is basically 1 times 6, which is 6, and 3 times 1, which is 3 on the bottom, and 6 divided by 3 is 2. Okay, so we get that the inverse function of 6 is 2. So what I'm going to do is I'm going to replace this with 2, and then I'm going to bring down that f, so we have f of 2. So step 3 would be to find f of 2. So I'm going to go up to my f function, and I'm going to replace x with 2. So we have 3 times 2, and that equals 6. Okay, notice the number that we started with is the number that we ended up with at the very end, right? Because that's our answer. That is always going to happen when you have f of its inverse function. The f and its inverse function, they're opposites, right? So what ends up happening is those two things cancel out, and you're just left with your x value. Okay, let's look at another example. Example D right here. We're going to try it again. So now we have the inverse function of f. Same thing, right? This was f of its inverse, now it's its inverse of f. Okay, same thing should happen. The inverse function of f and f should cancel each other out, and we should be left with 3. Okay, so let's try. We already found the inverse function, right? We found it over here. 1/3 x is our inverse function of f. Okay, so I don't have to find that again. I found it over here. So we know that, and now we're just going to focus first on finding f of 3. Okay, so step 1, we're going to solve f of 3. So I'm going to come up here to my f function, and I'm going to say 3, and then I'm plugging in 3. 3 times 3 is 9. Okay, so I'm going to replace this with 9, and I'm going to bring down the inverse of f. So step 2, we're solving our inverse function of f of 9. So we're going to plug in 9 into our inverse function. So I'm going to have a 1/3 times x, and our x is 9. 1/3 times 9, so basically 9/1. So 1 times 9 on top is 9, and 3 times 1 is 3, and 9 divided by 3 is 3, which is what we started with, because your function and its inverse cancel each other out, and you're just left with the x value. That will always, 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 always be the case, okay? And 9 out of 10 times, there's always one like this on your DCA, okay? The end of each 9 weeks. Okay, just gonna stick with these same functions up above, and we're gonna do one more example. This one is h of f of g of positive 2, okay? So the only difference in this one and the other ones we've done is that we have an extra variable inside of our parentheses. So we're finding h of f of g of 2. Man down. Messed up my video though. Okay, gotta try that again because I just spilled my water, as you may can see. Okay, so we have h of f of g of 2. Okay, so we're still gonna do just like we were doing before, and we're just gonna simply start in the middle. Okay, so step 1, we're gonna find g of 2. G of 2, so I'm looking at my g function, and I'm gonna keep everything how it is, but I'm gonna replace x with 2 in this case. So if I do that, I end up with 3 minus 2, which is 1. So g of 2 equals 1, okay? So I'm going to replace this with what it's equal to, which is 1, okay? I'm going to rewrite it down here because I'm running out of room. So I'm going to have h of f of, instead of g of 2, since g of 2 equals 1, I'm put a 1 in its place. Now this is just like what we were doing before with two variables, okay, or two different functions. Up here we started with 3, we solved one of them, now we're down to 2. So in step 2, I want to solve f of 1. Okay, so now I'm going to look at my f function. I'm going to keep everything how it is, but I'm going to replace x in this case with what it's equal to, which is 1. So we get 3 times 1, which is 3. So f of 1 is equal to 3. So I'm replacing f of 1 with 3. So we get h of 3. So then for step 3, we're going to solve that, h of 3. So we're going to go up here to our h function. And I'm going to keep everything how it is, but I'm going to replace x with 3. Okay, so then I get 4 times 3 is 12. And 12 minus 1 gives us 11. That is our final answer because we don't have any more variables, right? This was our last one. Our last function was h. We found our answer, so that is our final answer. Pretty easy, right?